Let's go ahead and practice some implicit differentiation together. So for this particular example, we're going to be going ahead and finding this dy dx if 3x squared plus 5xy squared minus 4y cubed is equal to 8. Let's just go ahead and start off by rewriting this. So this is the equation that we're dealing with in this example, and when we're going to go ahead and find dy dx, just try to remember that we're basically just going ahead and trying to find out the rate at which y is changing as x is changing. Now, while implicit differentiation can be a little bit intimidating, let's see if we can try to go ahead and break this down into some smaller pieces that are a little bit less scary. Now notice that we have some different terms here. We have this 3x squared, we have this positive 5xy to the second power, we have this negative 4y to the third power, and we have this 8. Now anytime we take a derivative of a term with an x in it, we need to go ahead and multiply that derivative by dx over dx. Hopefully this makes sense because we're taking the derivative of that x term in respect to x. And as for any terms with y, since we're taking the derivative of those terms in respect to y, we're going to go ahead and multiply each of those derivatives by this dy dx. So notice this first term has an x in it, so we'll have to multiply the derivative by dx over dx. This term has x and y, so we're going to have to multiply it by dx over dx and dy over dx. And this term over here has a y in it, so we will have to multiply it by dy dx when taking the derivative. This term over here doesn't have either, so we don't have to worry about this. And try not to think too much about this dx over dx because that's just equal to 1, so we're not going to really see that too much later on. For the sake of being as clear and consistent as possible for this video though, I'm going to be writing that dx over dx. Alright, let's start with this first term of 3x squared. Now if we go ahead and use the power rule, then we're going to go ahead and take this 2, and we're going to put it in front and multiply that 2 times 3. If we go ahead and do that, that's going to be 6, right? And then we're going to also still have this x, and then this 2, we're going to lose 1 from that, so 2 minus 1 is just going to be 1. So it's going to be 6x to the first power. Now we took the derivative of a term with an x in it, so we have to multiply this by this dx. So let's go ahead and multiply that by dx over dx. Now remember that this dx over dx is really just equal to 1, and we don't really have to write this exponent of 1 either, so we can go ahead and just simplify this down to saying this is going to be 6x. Alright, cool, so that's the derivative of that first term. Alright, moving on to this next term, this one's a little bit more complicated. We have this 5xy to the second power. We're going to have to go ahead and use the product rule here. So using the product rule, let's separate this into two factors. So we have this 5x for the first one and then y squared for the second one, right? So let's go ahead and call I'm going to call u this 5x for now, okay? And then what is du going to be? Well, du is going to be the derivative of that. The derivative of 5x is going to be equal to 5 multiplied by dx over dx, right? Any terms with an x in it, we're going to multiply it by dx. Now again, dx over dx is just equal to 1, so we can say du is just equal to 5. Now what about v? Well, we're going to call v here is going to be this y to the second power, right? So if we go ahead and take the derivative of that, or also known as dv, then dv is going to be equal to, use the power rule, is going to be 2y to the first power. Okay, take away 1 from that exponent, but then that's going to be multiplied by dy over dx. Alright, so what's this product rule going to look like here? Well, the product rule, remember, is u times dv plus v times du. So u is going to be 5x. Let's go ahead and take that 5x here and multiply that by dv. For dv, we're essentially going to just write 2y multiplied by dy dx. So let's have this dy dx next to it. So that's u dv. And we're going to go ahead and add v du. So what's v? V looks like it's y to the second power multiplied by du. Now du, I think, simplified just down to being the constant of 5. Now just going ahead and cleaning this up a little bit, that 5 times 2 is going to be just 10, and then we have 10xy. And then we're just going to have that dy over dx. So let's go ahead and put that right next to it. And then just cleaning up this y squared times 5, we can say it's going to be plus 5y to the second power. And so this derivative is a little bit more complicated, but we can go ahead and take this derivative of that second term and place that back over here. Alright, let's take a look at the rest of our equation. Alright, so for this next term, keep in mind that this is going to be a negative 4y to the third power. And if we go ahead and use the power rule for this derivative, we're going to take this 3 and put it in front and multiply by that -4. So 3 times that -4 is going to be a -12. And then we have this y, of course. And then we're going to take away 1 from this exponent. So 3 minus 1, that's going to be 2. So it's going to be raised to the second power. Now, this term does have a y in it. So remember, we have to multiply this by dy dx. So let's go ahead and do that right now. And I'll go ahead and say it's going to be times this dy over dx. Now this piece is as simplified as we can make it, so we're going to leave it just like that. And finally, we have this constant at the end. It doesn't have an x or a y, and hopefully you remember that if you take the derivative of a constant, that's just going to equal 0. Alrighty, so we have the derivative of each of those terms, 1, 2, 3, and 4. Let's go ahead and rewrite this so we have our derivative. So far we have this 6x plus this 10xy dy dx plus 5y squared minus this 12y squared dy dx is equal to 0. Alright, now what do we do with this mess? Let's go ahead and just focus in on these two terms because they both have this dy dx and that's what we are solving for. So we want to get those two terms together so we can get this dy dx together. So we want these two terms to be together since they both have dy dx. We can do that by going ahead and subtracting 6x from the left side and the right side, then subtracting 5y squared from the left side and subtracting 5y squared to the right side. If we go ahead and do that, we're going to be left with this 10xy dy dx minus 12y squared dy dx, and that's going to be equal to -6x plus this 5y squared on the right side. Now notice how both of these terms on the left side both have dy dx, so we're going to factor that out as a common factor. So factoring out this dy dx, this is what it's going to look like. So we have dy dx over here, and we're factoring that out and multiplying this by 10xy minus this 12y squared. On the right side, we're still going to have this -6x plus 5y squared. So after factoring out that dy dx, notice how we only have it written once, which is really nice. And it's being multiplied by this 10xy minus 12y squared. So let's go ahead and divide both sides by this 10xy minus 12y squared to isolate that dy dx. By doing that, we're going to have this dy dx alone. And on the right side, we're going to have this -6x plus 5y squared all over this 10xy minus 12y squared. And there you have dy dx, which we solve by using implicit differentiation. If you found the video helpful, please consider sharing it with a friend or classmate who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.